Hi everyone, Krishna this side. In this video, I'll be covering this Leetcode problem 2016, maximum difference between the increasing elements. Let us look into the problem statement first, then we'll discuss about approaches and I'll write down the code as well. Okay, so given a zero index integer array nums of size n, find the maximum difference between nums of I and nums of j. That is nums of j minus nums of I, something what we have to find, such that 0 less than or equals to I less than j less than n. So whatever the value of nums of j, it should be always less than nums of I, and also I is actually appearing first before j. Okay, so yes, we need to return the maximum difference. If no such I and j exist, we have to return -1. Okay, the problem is pretty much straightforward. So what is the given? This is the nums of array, that is what we have, and we have to figure out the nums of I, which where the I is actually less than j, and nums of j, and whatever the difference that we get, that should be the maximum. Okay, the pair could be anyone, but we have to make sure that whatever the pairs that we are choosing, the I should be less than j, and the difference is something what the maximum difference something of we have to figure out. Okay, so here 7 minus 1 also possible, but I, if we choose I as 7 and j as 1, uh this is not going to be acceptable, right? Because I should be less than j and nums of I should be less than nums of j. Okay, both the conditions should satisfy. So the basic approach, the idea, brute force idea that comes in mind is basically what we can do. We can start with a zeroth index first, then we will check which is the next smallest element. So two for loops we will run. In the first for loop, we will go at that particular index, and we will check from that next values from that particular index, which is the next largest value that we can get, and we can simply try out different possibilities, and we can get the answer. Okay, this will take n square, and yeah, with that way we can solve this one. So constraint also, in the constraint, if we look, the size of this n is actually less than 1000, so there it is, we can write the solution with the n square. Okay, if we look into the constraint, but yes, of course we can solve it in better ways, right? So what if we figure out which is the smallest value so far at that particular index, if we get to know that the smallest value appeared, which was appeared in this array previously, whichever the value that was there, if we have somewhere, if we tracked that value, we can easily get the difference between the values and it, right? So what I'm trying to say is, let us say here we have this array, correct? 7 1, let us say 2. Well, let me give the space. Instead of 2, I'll write 4, 5. Here, then it is 2. Here it is again 7. Then 1. Then 8. Then 9. Okay. This is the array that we have. Let us say we are trying to figure out the smallest value when we are reaching to any particular index till there, which was the previously smallest value, something that we are trying to figure out, so that whenever we are at that particular index, we can simply subtract with the smallest value. If we get the maximum difference, that is something what we will update into the answer. So what I'll do is, I'll create a small which we can keep on tracking. Currently it will point to zeroth index. Okay, because this is the value which we will be having smallest, right, till this array's index, correct? Now what we do is, basically we will start from here, and we keep on checking if the new value that we got, if it is the smallest compared with the previous value. If so, we will update the smallest value. Okay, if not, we will get a differences. Okay, so now we are at this particular index, first index. We check that if the small value that we have is less than this value or not. So if this new value is smallest, we will update that one. Okay, that is the first operation that we will do. Now we are at this particular index, so we will check that is it smallest than this one. No, it is not. So what we can get, we will update the answer. What is the answer? 5 minus 4, because that was the smallest value so far that we got. The answer is basically 1 now. Okay, so far, if we have this much, this is the array that we have, definitely 4 and 5 is the pair that we will be looking at, and the answer is going to be 1, correct? So yes, that is the answer that we got. Now what we can do, the answer is basically 1, the small value is 4 so far till this index. Okay, Next thing is we'll be at this index. Second value is what we have. Is it smaller than this value? Yes, it is. So small is getting updated. Okay. Next value is 7. 7 is is this smaller than this one? No, of course not, right? So what we can do? Answer was previously say 1. Now what we can do is 7 minus 2. Okay, because so far in this array this was the smallest value that we track. So 7 minus 2 is of course going to be 5. 5 is actually greater than this one. So maximum difference that we got is 5. Correct. So we are just tracking out which is the smallest element that we got so far. So that definitely this will be I for us from this values, and the next is going to be j for us, and we keep on checking if it is the smallest one or not. If so, we will update it. Now we are at this location 7. Basically one is smallest comparing with 2, so we updated it. Now next is 8. So 8 is obviously greater than this one. So what we can do is, previously the answer was 5. We will check that 8 minus 1. So it is basically giving us 7. 7 is actually greater than 5. So the maximum difference, that is something what we got. So we update the value, okay, to 7. Next one is 9. So basically 9 is actually less than this one, sorry, greater than 1. So of course we will again check that 9 minus 1, the difference here we got 8. So the answer, maximum answer that we can get is 8. So that's how we can solve this one, pretty much easy. So if you got the logic, you can write down the code as well. So what I'll do is I'll create a small, and currently it will point to nums of course 0, whatever the first index that we have. Let us create an answer, and as they have said that if we do not get any pairs, we have to return -1. Okay, in this example. Okay, so see, 9432 is something what we have, right? So if 9432 is something what we have, 9432, of course the first small is basically 9. The answer is basically pointing to -1. Next is like we check that 4 is actually small, so small is getting updated. Next is 3. 3 is basically less than 4, so 3 is got updated. 2 is basically less than this previous small, so 2 is something what we updated. So here the answer, we never updated the answer, but the small values keep on getting updated. That then answer is something what we are returning, right? So that is what we will do. So we'll run a for loop for int I equals to 1, I less than nums of nums dot length I plus plus. Here what we do is basically check that if this small is basically whatever the previous small that we have, if it is less than nums of I. Yes, if it is less than, so we simply update the answer. Answer equals to mat dot max, previous answer whatever it was having, and this new value nums of I minus small. Okay, if not, else we can write that small equals to whatever the new value that is there, that is something what we update into the answer. Okay, that is how we can write this one, then we return the answer. Okay, because else condition is going to be the pretty much same, right? Like if it is not, then definitely the small whatever at current element is going to be the smallest one. Okay, let us submit this code. And talking about the time complexity is going to be big O of n. So yes, we are solving it in n time complexity, and we are not holding any space and all. So yes, it is constant. Okay, so that's all from this particular video. Yeah, thank you for watching this one. Bye bye.